So let's do an example with the functions. So let's say a function f of t equals 3t plus 1. If we were to say find f of 2, all we need to do is just put the 2 wherever there is a t. So 3 times 2 plus 1, that equals 6 plus 1, we have 7. What about f of negative 4? Same rules. So 3 times negative 4 plus 1, that gives us what? Negative 12 plus 1, which is negative 11. Finally, third example, f of t plus 2. We just put the t plus 2 where there is a normal t, so that is 3 times t plus 2 plus 1, which equals what? 3t plus 6. Have to distribute the 3 evenly. Plus 1, so this gives us 3t plus 7 here on the bottom. So these are our 3 answers. Now let's expand that idea a little bit and put it into a set. So what if our function is a set? So f of x equals a set x plus 2 when x is less than 0, 4 when x is between 0 or equal to 0, greater than or equal to 0, and less than 2, and x squared plus 1 when x is greater than or equal to 2. So first example, let's say, what is f of negative 2? Well, negative 2 for our x is less than 0. We use the function x plus 2. So we just take that negative 2, plug that into x plus 2. So that's negative 2 plus 2, and we have 0. Next, what about f of 1? So in the first one, our x is negative 2, our y is 0. Remember, our y is dependent on whatever the x is. Second one, f of 1. Well, 1 is when x is between 0 and 2, it's 4. So our answer is 4. Next one, f of 4. f of 4 equals, it is greater than 2, so we're using our x squared plus 1, right? X squared plus 1. Plug 4 into that. That equals what? 4 squared plus 1, which is 16, plus 1. Our answer is 17. Lastly, what about f of 0? Well, 0, notice here, when x can equal 0, so then in the middle equation, so our answer is just simply 4.